Pacific is cracking open. On July 29, 2025, a magnitude 8.8 megaquake ripped through Russia's Kamchatka Peninsula, the biggest quake since Japan 2011. But here's the nightmare. Scientists warn it may not stop there. One rupture could trigger another, unleashing a chain reaction of megaquakes across the Pacific Ring of Fire. Let's start with what just happened. The Pacific Plate lurched beneath the North American Plate along the Kuril-Kamchatka subduction zone. The rupture tore open a fault stretching nearly 600 kilometers long and 200 kilometers wide. That's an area bigger than the entire state of Florida. The seafloor shifted by as much as 14.5 meters in places. Imagine a city block instantly jumping forward by half its length. The shock lasted nearly 4 minutes. For context, most earthquakes last just seconds. 4 minutes is enough time to wonder if the world is actually ending. Kamchatka, this volcanic claw of land jutting into the Pacific, has always been a seismic monster. This isn't random. The Pacific Plate here dives beneath the edge of Russia at nearly 80 millimeters per year, one of the fastest rates of subduction on Earth. Over decades, the plates get stuck, pressure builds, and then boom. The last time this section really tore was 1952, when a magnitude 9.0 quake launched a towering tsunami that killed thousands in the Kuril Islands. Before that, in 1737, records describe waves over 60 meters high, about the height of a 20-story building. So when this latest quake ripped loose in 2025, scientists weren't exactly surprised. But what came next caught everyone off guard. Volcanoes, lots of them. Within hours, 7 volcanoes in Kamchatka erupted. Some had been restless, but one, Krasheninnikov, hadn't erupted in all of recorded human history. A 6-kilometer-high ash plume shot into the sky. Kluchevskaya Sopka, Eurasia's tallest active volcano, roared to life. It was like the Earth was peeling back layer after layer, venting its fury. Volcanoes and earthquakes are often cousins, born of the same tectonic forces, but to have this many erupt in a cascade, scientists say it hasn't happened here in nearly 300 years. Meanwhile, the tsunami alarm screamed across half the planet. Japan issued its first nationwide tsunami warning since the 2011 disaster, evacuating 2 million people. Hawaii ordered evacuations of entire coastlines after gauges on Midway Atoll recorded waves almost 2 meters high. From Russia to California to Chile, alerts rolled in. Some places got off light, 30-centimeter surges lapping harbors. But in Russia's Kuril Islands, the water rose 19 meters high in places. Imagine a wall of water taller than a 6-story building plowing inland. In one town, Severo-Kurilsk, 90% of chimneys collapsed and the port was smashed to splinters. The scariest part? Scientists later estimated that in some remote stretches of Kamchatka's coast, waves may have peaked at 43 meters high. That's as tall as the Statue of Liberty. But here's where things take a darker turn. This wasn't just a one-off quake. In the 10 days leading up to it, seismologists counted 50 earthquakes above magnitude 5, including a 7.4 foreshock just days before. And after the main quake, over 1,200 aftershocks rippled through the crust in just the first week. The USGS put out a forecast: 2% chance of another quake above magnitude 8, 24% chance of one above magnitude 7, and a greater than 99% chance of more quakes above magnitude 5. In other words, the ground under Kamchatka isn't done moving, not even close. Now let's zoom out, because this isn't just about Kamchatka. The Kamchatka quake sits on the Pacific Ring of Fire, a 40,000-kilometer horseshoe of volcanoes and subduction zones encircling the ocean. This ring produces about 90% of the world's earthquakes and 75% of its volcanoes. And here's the terrifying pattern. All 10 of the most powerful earthquakes in modern history have happened on this ring. When one section slips, it redistributes stress to neighboring sections. Think of it like popping bubble wrap. Pop one and the pressure shifts down the line. Scientists call this cascading failure. And right now, pressure is stacking up in some of the most dangerous subduction zones on Earth. Places like Japan, Alaska, Chile, and maybe most ominously, the Pacific Northwest of the United States. That's where we're headed next? The Kamchatka megaquake might be just one domino in a much larger game. To understand why, we need to zoom out across the Pacific Ring of Fire. This ring is not a neat line, but a chaotic horseshoe running from South America up through Alaska, down past Japan, and deep into the islands of Southeast Asia. It's stitched together by subduction zones, those immense geological seams where one plate plunges beneath another. Each seam is like a spring being wound up over centuries. When it finally snaps, it unleashes the kind of destruction we saw in Kamchatka. And scientists are increasingly worried that Kamchatka's rupture may have redistributed stress in ways that could load up other seismic hotspots. Let's start with Japan. The 2011 Tohoku earthquake, magnitude 9.1, generated a tsunami that killed nearly 20,000 people and triggered the Fukushima nuclear disaster. It was the most powerful quake ever recorded in Japan, and it shifted the country's main island eastward by 2.4 meters. Japan sits right next to Kamchatka on the Ring of Fire. When Kamchatka's fault ruptured in 2025, scientists noticed unusual stress redistribution pushing southward, directly toward northern Japan. And here's the kicker: parts of the Japan Trench remain locked, meaning they haven't slipped in centuries. In seismology, a locked trench is like a loaded gun. Already, seismologists in Hokkaido have warned that an M8 class earthquake is possible within the next 30 years. After Kamchatka's rupture, that clock may have just sped up. Now look east, across the Pacific to the United States. Stretching from Northern California up to British Columbia is the Cascadia subduction zone. If you've never heard of Cascadia, think of it as America's version of Tohoku, a fault capable of magnitude 9 megathrust earthquakes and ocean-wide tsunamis. The last Cascadia megaquake happened on January 26, 1700. We know the exact date because Japanese fishermen recorded an orphan tsunami, waves rolling ashore without a local quake. When scientists compared that with tree ring evidence in North America, they realized it was Cascadia, unleashing an estimated magnitude 9.0 quake. That was 325 years ago. Geological records show Cascadia produces a megaquake every 250 to 500 years. Do the math, and you'll see why scientists at Oregon State University call Cascadia overdue. One FEMA report predicted that a full rupture of Cascadia could kill up to 13,000 people and displace over 1 million in the Pacific Northwest. Economically, it could be the costliest natural disaster in U.S. history. And now, with Kamchatka freshly ruptured just across the Pacific, some geophysicists are asking, could that stress transfer ripple all the way to Cascadia? This isn't just theory. Look back at 2004. The Sumatra Andaman earthquake, magnitude 9.3, ripped open a fault more than 1,400 kilometers long, the longest rupture ever recorded. That quake triggered aftershocks up and down the fault for years, but it also seemed to wake up nearby subduction zones. Just 3 months later, an M8.6 quake struck off Sumatra. In 2005, another M8.6 hit Nias Island. And in 2007, an M8.5 rocked Bengkulu. It was as if Sumatra had set off a rolling cascade, one plate boundary shaking the next. Scientists now wonder if the Pacific could see something similar. Kamchatka, slipping in 2025, followed by another rupture somewhere along the Ring of Fire in the years to come. The data is sobering. Globally, there have been 10 magnitude 8+ earthquakes since 2004. Compare that to the average of about 1 per decade over the 20th century. Some geophysicists argue we may be entering a period of heightened seismic clustering, where multiple megathrusts happen within decades rather than centuries, and history backs this up. In the mid-20th century, the world saw a bizarre sequence of giants. The 1960 Chile quake, M9.5, still the largest in history, followed just 4 years later by the 1964 Alaska quake, M9.2. Within 15 years, 3 more magnitude 8.5+ events shook the Pacific. Clusters like this suggest Earth sometimes releases its tectonic stress in bursts, violent, world-changing bursts. But why does this matter now? Because the Pacific Basin is home to over 800 million people living along its coast. Cities like Tokyo, Seattle, Santiago, and Manila all sit within reach of megathrust-generated tsunamis. And infrastructure has never been more vulnerable. Nuclear plants, undersea internet cables, ports that move 40% of global trade, all of it can be crippled by a single quake. Take the Kamchatka event. Even though it struck in a relatively remote region, it caused tsunami warnings for 22 prefectures in Japan, disrupted airports, shut down bullet trains, and even damaged a Russian nuclear submarine base. Imagine what happens if the next one hits closer to Los Angeles, or Manila, or Lima. It starts with one rupture. Kamchatka, for example. Stress redistributes, pushing the next fault closer to failure. That quake then triggers its neighbor, and on it goes. Each quake is devastating on its own, but together they reshape entire societies. We've seen smaller scale versions of this. In 2016, a series of mid-sized